eruption within a few days. The weight of the rain-ash duo caused many buildings to collapse. On the flip side, it briefly cooled the planet. Temperatures likely dropped by over 0.5 degrees Celsius. So does this mean a large volcanic eruption in the future could lower temperatures, briefly blunting the effects of climate change? Volcanoes are cracks on the Earth's crust that spew lava, ash, and gases. Water vapor, carbon dioxide, and sulfur dioxide make up 99% of the gas released. The remaining 1% comprises small amounts of hydrogen sulfide, carbon monoxide, hydrogen chloride, hydrogen fluoride, and other minor gas species. Inhaling them could threaten human health. The ash could contaminate drinking water. The eruptions could unleash disasters such as floods, power outages, and wildfires. Though destructive, volcanoes have played a crucial role in making Earth habitable. In the early years of our planet's existence, water vapor that entered the atmosphere condensed into oceans, allowing life to take off. Further, molten rocks that escaped the interiors eventually cooled to form volcanic rocks. Some broke down or weathered over time to release nutrients such as potassium and phosphorus into the soil, making it fertile. Humans thrived as a result. And in our march towards development, we put the planet under duress. As a result, the average global temperatures rose by 1.1 degrees Celsius since the pre-industrial era. The 2021 IPCC report warned that temperatures would likely breach the 1.5 degrees Celsius limit in the next 20 years. The report also offers a glimmer of hope. Based on historical data, scientists predict a large volcanic eruption this century. This eruption, they say, would reduce global surface temperature, rainfall, and snowfall for over 1 to 3 years. Such an eruption might give us a temporary respite from human-caused climate change. So how could something as destructive as volcanoes cool the planet? To understand that, let's look at how Mount Pinatubo impacted the global climate following its eruption on June 15, 1991. Clouds of ash and gas from the eruption made its way high into the stratosphere, which extends from 10 to 50 kilometers above the ground. About 15 million tons of sulfur dioxide reached the stratosphere. It formed a sulfur dioxide cloud, the largest recorded since 1978. In the stratosphere, the gas reacted with water to form sulfuric acid droplets. They became a part of aerosol particles, which are tiny liquid droplets suspended in the air. Researchers say these particles can remain in the stratosphere for 3 to 4 years after the explosion. According to a study, it took about 3 weeks for the aerosol cloud to spread around the world. So, what happened in Mount Pinatubo did not stay in Mount Pinatubo. Consequently, the average global temperature is thought to have dropped by about 0.5 degrees Celsius over large parts of the Earth between 92 and 93. This happened because the sulfuric acid-rich aerosol particles reflected the incoming sunlight into space. Think of them as nature's sunscreen. Sulfur dioxide aerosols are bright and hence reflect sunlight. Darker particles, on the other hand, absorb sunlight. For instance, when black carbon aerosols land on ice, they accelerate melting. This is happening in the Arctic. We have covered it in our previous video. Coming back to volcanoes, Mount Pinatubo wasn't the only event that affected the climate. Back in 1850, Mount Tambora in Indonesia erupted, resulting in a year without a summer. It injected 12 cubic miles of gases, dust, and rock into the atmosphere, making it the most destructive blast recorded in the last 10,000 years. Massive volcanic blasts are typically expected every 100 years. We cannot be certain that a massive volcanic eruption will occur by the turn of this century. In the meantime, a few scientists are toying with the idea of artificially introducing sulfur aerosols into the stratosphere. The goal is to cool the planet. Will that work? Well, it's a controversial subject. We'll dive deeper into the topic in the second part of our episode. Stick around.